Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. If you know you have not subscribed, please subscribe, share to your colleagues. We are going to look at the application of Laplace transform. First, we look at on the ODE, and the second, we look at on PD. The PD, where we will look at how to use that one to solve wave and heat equations and even the Laplace equations. Very good. So let's look at the first example here. This is ODE question, right? So if you want to solve this, they are giving y prime prime minus y equals e to the power 2t, y is 0 equals 0. These are the initial conditions. And we want to use the Laplace transform to do that, the application of it. In fact, we have solved a question like this. If you look at my previous video, a question like this has been solved on the Laplace transform on derivatives. So let's see how we can solve this. First, we know that y, this one at s, if I transform this, become y of t, right? If I also want to transform this y prime prime of s, if I transform this, it becomes s squared y, sorry, this one is t, and here is what s. Thank you very much. So s squared, so here is t of s minus s y of 0 minus y prime of 0. So this is what we have. Let's also transform e to the power 2t. So this one should know from the table that this will give you 1 over s minus what? 2. So this is what we have. So all that we are going to do here is to substitute this back into this one. So this is going to give us, now y prime here is this, right? So this gives us s squared. I'm taking off the s from there. Y of 0 is 0. So 0 times s is 0. So that one goes to y prime of 0 is 1. So we have minus 1. Then minus y, because my y is still y. So that one gives you that. Equals to e to the power 2t is 1 over s minus 2. S minus 2. So this is what we have. Now in this case, what we are going to do here is that I can send this one to the other side so that if I factorize y out, I have y bracket open s square minus 1 equals 1 over s minus 2 minus, so plus 1. So in this case, because this is negative, going there become positive. So here I'm going to have y s square minus 1 equals, if I find the LCM of this, I'm going to have s minus 1 all divided by s minus what? 2. That's if you find the LCM. This is what you get. Now let's divide through by s square minus 1. So let me come here. If I do that, I have my y equals s minus 1 all divided by s square minus 1. Then already this one is already here. S minus 2. This one is difference of 2 square. If I put a square here, so I can expand this one. So I have s minus 1 divided by s minus 1, s minus, oh sorry, plus 1, then s minus 2. So this is what we have. So at the end, this goes with this one, leaving y equals 1 over s plus 1, s minus 2. Is that okay? Now, the previous one we did, when you get to this place, that's ends it. But if the question asks you to do any question of this sort, after that, you have to apply the inverse transform, so that, see, the question was given to you in terms of t, okay, and now we have it in terms of s, so you have to take the inverse of this so that you go back to the t. But this one, there's nothing in the table that can help us to take the inverse, so you need to apply partial fraction on this. Is that okay? So let's look at how we can apply the partial fraction on that. Okay, so you're going to apply partial fraction on this. You know that 1 over s plus 1, s minus 2 can be written as a over s plus 1 plus b over s minus 2. I hope you're okay with that. Good. So with this, we can say that 1 is equal to a bracket open s minus 2 plus b bracket open s plus 1. This is a partial fraction. So for this one, when s equals positive 2, okay, this side goes to 0. So that I have 1 equals 3b. If I put 2 here, to be 2 minus 2, which is 0. So that one goes to 0. 2 plus 1 is 3, 3b. So we get this. Means that my b is equals to 1 over 3. Now let's also look at when s equals negative 1. What happens? This one goes to 0. If I put negative 1, I have negative 3. So I have 1 equals negative 3a. Means that my a is equals to negative 3. Sorry, negative 1 over 3. So this is what we have for a and b. So let's come back and substitute. It means that my y, you see, now it is in terms of s, equals to our a is negative 1 over 3 all divided by. So in this case, let me do this. Let me bring the b first, okay? My b is positive 1 over 3 all divided by s minus 2 minus 1 over 3 all divided by s plus 1. Is that okay? So this is what we have. Let's clean this side. So now I have my y at s equals, I can factorize it 1/3 out. If I do that, I have 1 over s minus 2, 1 over s plus 3. S plus 3, right? So this is what we, sorry, s plus 1. So this is what we have. Now, if you go to the table, we are going to take the inverse transform of 1 over s minus 2. So from the table, the inverse transform of this will give you e to the power 2t. And also, you take the inverse transform of 1 over s plus 1. From the table, that gives you e to the power t. So you just come and substitute. Means that our final answer, now it is in terms of t, so this one becomes t is equals to 1 over 3 outside e to the power 2t minus e to the power t. That is how we do the transform, and that is our final answer to that. Let's solve another example. Now let's look at this. We have to solve this. These are the initial or the auxiliary condition that is given to us. Okay, so first thing to do, let's write them. Let's transform them first. So y at t, if you transform this, you have y at s. Then y prime at t, if I transform this, I have s at y minus y at 0. Then I have this last one, which is y prime prime of t. By transfer, I have s squared y of s minus s y of 0 minus y of 0. This is prime. So this is what we have. T from the table, this will give you 1 over x squared. Is that okay? That is from the table. So you just go and substitute. So let's do the substitution. Y prime prime is this one. Okay. I'll be taking off the s from it. So it should become x squared y of 0. Y of 0 is negative 1. Negative 1 times x will give you positive, because there's negative s. Y prime of 0 is 2. So you have minus 2. That one is done with the substitution of this. Minus 10 bracket open y prime of t is this, right? You know that y of 0 is negative 1, so here become positive 1. So we have sy plus 1. Then the last one will be repeated is also 9y. And this is equals to 5t. But t is 1 over s squared. So we have 5 over s squared. So this is what we have at the end. Here, the aim is to be able to make the y the subject here. So we are going to have, let's open the bracket there. Right? equals to 5 over x squared. Is that okay? So 5 over x squared. So this is what we have. This, and that have y. So I can factorize y out. So together I'm going to have x squared minus 10s plus 9. So this is what I have. And this is equals to 5 over s squared. Now I'm going to send everything here to that side. So this is positive s. When it goes to become negative s, negative 2, negative 10, that is negative 2. Going there become positive 12. So let's find out LCM from this side. So I have my y, bracket open, s squared minus 10s plus 9. S squared minus 10s plus 9. And this is equals to, if you find LCM of this, we have 5 minus s cubed plus 12s squared plus 12s squared, okay, divided by s squared. Now, if I divide both sides by this, you see I'm going to have y equals 5 plus 12x squared minus x cubed. I'm just rearranging. All divided by x squared, bracket open, x squared minus 10s plus 9. So this is what I have here. Since that I have this, I need to break this one down. Okay, good. So let's try to break this one down so that we can use the partial, because we cannot get this one from the table, so that we can do the inverse plan. So we are done with the computation for this. We're left with the inverse for. So what I'm going to do here is that this one, x squared minus 10s plus 9. Don't expand this, okay? Let's see something here. You know that this one can be written as x squared minus 10s. We just need factors of 9 such that if I multiply them, I get positive 9. If I add them, I get negative 10. And that will give you, to be negative 1 and negative 9. So here will become s minus 9s plus 9. So I have s out, s minus 1, minus 9 out, s minus 1. So I have s minus 9, then s minus 1. So this is what I have. So in place of this, I'm going to put this one there. So I have y equals 5 plus 12 s squared minus s cubed, all divided by already I have x squared here, bracket open, s minus 9 here, then s minus 1. So this is what we have. This is perfect, right? Good. Now at this point, this is where I can apply what one of my partial fractions is. So I have 5 plus 12x squared minus s cubed, and all this divided by x squared, s minus 9, s minus 1. So this one can be, you see, this is repeating, so it becomes a over s, right, plus b over x squared. That is when it's repeating. That's how you do it. Before you come to c over s minus 9, then d over s minus what, 1. Is that okay? So this is what I have for it. Now we can then write this one as 5 plus 12x squared minus x cubed to be equals to, find the LCM. This gives us a s, bracket open, s minus 9, s minus 1. Then you have b, s minus 9, s minus 1, right? Before you move to c, x squared, s minus 1. Before you go to d, s squared, s minus 9. So these are the things that we are going to get if you find out. This is what you get. Now, after everything, if I've done my workings here. So what I have here is that if I take s to be 0, if I take s to be 0, then I'll get b to be 5/9. That's what I have. Then also, if I take s to be 1, if I take s to be 1, then I get d to be -2. D to be -2. Then if I take s to be 9, then I'll get c to be 31/81. Then the last one is where it's difficult to get the a. Where we have taken when s is 0, everything here goes to 0. And this and that also goes to 0. Sorry, this will go to this goes to 0. But see, all this side will go to 0. Here will go to 0. That's why we had the b. When s is 1, we get it. When s is 9, we get it. But how do you get the a? For you to get the a, what I did was that I just pick when s is +1, or you can also take it as -1. Whatever number you pick. Already we have used when s is 1, so take -1. If you put it there, though they are not going to go to 0, but already you know b, you know d, you know c, so you just substitute everything, and that will help you to get your a to be 50/81. So this is what you're going to get at the end. All right, this is what you're going to get. So you're going to have y at s equals, now my a is 50/81, right? So I have 50/81 s, but I can write it as 1/s like this, so that it will be clear. My b is 5/9, so plus 5/9, 1/s squared. Then c is 31/81, 1/s minus 9. Then the last one minus d is 2, so 2/s minus 2. So this is what we have. This is very simple to do, right? This one, for it to be easy for me, I can write it as -2 multiplied 1/s minus 1. So this is what I have. So let me clean this side. So I'm going to transform this back to the t. So if I transform it, I have 50/81. For the table, this one means what? 1. Because if I transform this gives me 1/s from the table. It tells me that this is 1. 1 times this will give you the same thing. So plus, from the table, 1/s squared is t. So we have 5/9t. And from the table, 1/s minus 9. So plus 31/81. Into s minus 9 from the table is e to the power 90. In the last one, minus 2 e to the power t. So this is what we have as our final answer. Thank you very much for watching. Please, our next video will be on PD. Thank you.